the equations. So first off, on the I hat A, what are all the forces in the positive I hat direction?
Tension.
In the positive. Friction is not in the positive. Looking at the forces acting on A. And that's it. I would, if I had more than one, I would just do plus, just put a plus sign in between them. What about in the negative I hat direction?
Friction.
So minus the friction equals, since that's it for my horizontal there, is equal to the mass of A times the acceleration. Now the J hat. Now I know we've just introduced this. Anyone want to take a shot at what the J hat equation is going to be?
YA minus the WA.
Negative y.
Oh yeah.
Because of what you said.
Yeah, it's my fault.
Okay.
Plus
Plus
WA.
WA.
Equals the mass of A times 0. The whole purpose of picking a coordinate system so that one of the coordinates is in the direction of acceleration is so that the other equation is going to be equal to 0. We could set it up so that they are, neither of them are equal to 0, but that's only if you just love doing the algebra. So this is the second equation. Now we're down to mass B.
So WB minus tension equals mass of A times mass of B times A.
All right.
Wait, that for J hat or I hat?
I listed this as I sub B.
Oh.
My I is curled to the right, my J is curled to the left.
So we would have said tension minus WB, would that still be right, or?
We chose down to be positive in the direction of acceleration.
Oh, okay, so that's.
If we had chosen up to be positive, then the equation would have been Ft minus WB is equal to M times negative A. Because the acceleration is still down regardless of what direction we pick. Laura?
So why exactly do we need two separate coordinate systems for each thing if B is going in the same general direction? Does that make
In this case, if I just set to the right is positive and down is positive, then I could have done it.
Okay,
But later on, it's not necessarily convenient to do that.
okay.
Because, and this gets into part of the ideal aspect of the room. Because it is stretchless, they will accelerate at the same rate. That the magnitude of B's acceleration and the magnitude of A's acceleration are the same. That's why I can get away with the same letter here and here. And I don't need subscripts for the acceleration. Questions up to here?
Do you remember when you get moved up to 0 for the J hat?
Say it again.
Do you remember how we got to 0 for the J?
The formula is force equals mass times acceleration. Because the acceleration for box A is to the right, well, vertically, that means there's no acceleration. So that's why that's 0. Margaret?
So, just to clarify, like, you could have just used the I hat A and J hat A, but like in other problems, we would have to use the I sub B.
Well, you will use I sub B in this problem too. So, sorry, I think I understood your question.
No. It's kind of like what she was asking, like what, you have two separate ones. Like, why can't you use the top left, like, for box B?
Oh, make that the J hat A direction?
Yeah,
I could have.
okay,
But what I'm trying to get towards is you don't have to. That, since the direction, the main thing is what is the direction of acceleration of the two boxes? And so I deliberately chose a different letter because there are problems where it'd be really inconvenient if you tried to force the same coordinate system for everything.
right.
Alan?
Question, Ellen. I had two questions, and I think that I have solved the first one.
Okay.
MA and MB is the mass of a box A and box B respectively, right?
Yes.
Okay, so if I had subscript A equation, what's that last here, or is that just an A?
That's an A.
Okay. Wait, what's the last character from J hat?
That's a 0.
Okay.
If I put a slash through it, it's a 0. If I don't put a slash through it, then it's either an O or a 0. Okay. Now, substitution. Now, there are certain formulas for, certain quantities that are going to be true independent of the problem. For example, there is a formula for weight. And so, if we think about this equation right here, Newton's second law of motion, if I take an object and drop it in a vacuum, what are all the forces acting on it? Ooh,
Gravitational force?
yes.
In a vacuum, if you took all the air out,
Yeah, there's still gravitational force.
Yeah.
Gravitational force does not require contact. What Newton would have called action at a distance. So if I have an object that is in free fall, I have weight acting on it. That's the total force. So my force is W is equal to the mass times the acceleration. Well, if it's accelerating under the force of gravity only, it's the acceleration due to gravity. So that is the formula for weight. That is mass times acceleration due to gravity. That is not mass times gravity. That is acceleration due to gravity. It is also, as some screen readers will say, it is not milligrams. It's mass times acceleration due to gravity. Or, as we shorten it to, mg. So wherever I see W, I'm gonna put in it mg. So I'm gonna take my first equation, Ft minus the friction is equal to m subscript A times A. Then I have, I'm gonna flip this around, jotted scars and all. MAG minus YA is equal to 0, and MDG minus tension equals MD times A. So all I've done here is done the substitution. Instead of weight, I have, instead of weight A, I have MAG, and instead of weight B, I have MDG. That's what I mean by substitution. There's also an independent formula for friction, but I'm not going to subject you to that yet.
So that means it's hard.
So
I'm sorry, so does MG always have to be in front?
no, I just like the first thing to be positive.
Okay.
That was the job to start. If you want to put negative YA plus MAG equals 0, the math people say it's fine. Question is, do you trust those math people?
You've never not referred to them as math people.
How should I refer to them?
I don't know, but it's interesting.
So then it kind of goes back to my first question again. So if you would have done negative FT plus WV, it would still be the same and it wouldn't be the opposite of what.
Correct.
Okay.
All right, so for this problem, let's just assume friction is 0. And I'm gonna do shorthand. You would have seen it before when we were doing the test level problem for plus minus 0. Those are the Greek letter lowercase mu. It is the symbol for the coefficient of friction. The subscript K is the coefficient of kinetic friction. That is a coefficient based upon whether things are moving or not relative to each other. And S for static, the friction when things are not moving. I push on this table, there's static friction that's keeping it in place. As soon as it starts to move, it's kinetic friction acting on it. So I'm establishing there's no friction here. So my problem now is this top equation now reduces to tension is equal to mass times acceleration. Mass of A. So I have tension is equal to M subscript AA. And then the last equation, I have MBG minus FT is equal to MBA. And now, typically you're gonna solve for acceleration. There are many ways of doing this. We need to get rid of tension. I'm trying to mass, presumably I know the masses. We'll consider them known. So I know M. Presumably I know the planet this is on, so I'm gonna know what G is, at least the two significant figures. Acceleration and tension are the unknowns. Typically, you're finding acceleration, so I don't need to know the tension, so I need to get rid of it. I can either do substitution, because I have tension is equal to this, plug it into here, or I can just add the equations. If I add the left-hand sides, I have MBG. I have a positive tension and a negative tension, they cancel out. And on the right-hand side, I have M subscript A times little a plus M subscript B times little a, which is MA plus MB times little a. So in our nice little frictionless ideal world over there, we'd end up with acceleration is equal to MBG divided by MA. One too many curls there, MA plus MG. And that would be the formula for this problem.
Dr. Fox?
Yes?
Can you explain again why I remove friction from the equation? Is it just
Because we haven't talked about friction yet in enough detail for me to harass you with that.
Alright.
I'm saving it.
So,
If someone's birthday's coming up, maybe I'm saving it for that birthday.
That's kind of mean.
so we have just ignored it?
Yes.
So would any of this calculation even be right since we have ignored it?
Would it be right? I mean, as in if we did this experimentally?
Well, no, but like, it's just not important to solve the current problem?
Well, the current problem is I made it frictionless.
Right. Alright.
Don't worry. For those people who really like realism, we'll add some in. Not all of it, some of it. Or?
Can you re-explain how you went from, tension equals MA acceleration, and then MB, G minus, oh, I wrote it wrong, that's why, never mind.
Okay.
I understand.
That ain't help. Other questions?
I don't quite understand how we got that.
Oh, you got it from here to here?
Yes.
Okay. The question Laura was afraid to ask.
Yeah, I mean, debatable.
Oh, yeah.
Sorry, we'll go back to it. All right, that's what we had.
Yes.
As long as I add equal things to both sides, the math people say it's okay. So what I'm gonna do is on this right here, I'm gonna add this. So I have FT plus MB minus FT. Over here, I'm gonna take that. Oh, that's MAA. And I'm gonna add to it the equivalent of this, which is MBA. I have a tension here and a negative tension there, and they cancel out. So I'm left with MB equals that.
Wasn't it MVG on the last side?
Oh, yes, you are right.
So then we're going to
Without friction, that other equation actually has no impact. Yes, we did ignore it. Physics typically starts with the simplest case, and then you just add a little bit of realism, then a little bit more realism, and eventually you're heading towards. I was trying to wait until after the course is over before you head to the split. Because it's a lot of paperwork. All right, now I'm just gonna flip it back because I think there was a desire to see the old page. So that is the basic process that we will go through. The only difference is new situation, new force diagram, new set of equations, but the process is the same. Now, for those of you who have had physics before, some of you can see the shortcuts already, and there's no harm in taking them. Other times I've had people who've had physics before who basically did not learn the process and did not know when it was appropriate to take the shortcuts and took just really bizarre, because they looked kind of like a problem they'd done before. And they ended up basically being hurt by it because they thought, oh, I could have done this easily. And yes, there's a much faster way of doing it. But as the problems have become more complex, it is very useful to at least have some sort of steps to go through to get there. Right. Any? Yes?
Can you show us when we would have to decompose a force? Because I
When
don't.
you have to what?
When we have to do a decomposition. When do we have to do that again? I forgot already.
Poisson ramp.
When it's not on the J hat I hat direction, so that was like on a.
Well, all right, so a decomposition example. The force diagram, I believe we've done. I have normal force acting this way, I have weight acting down, I have friction acting back. So that direction of acceleration. Which way will this accelerate if it's going to? So my acceleration is in that direction. So I'm going to set up my coordinate system accordingly. I'm going to set up I hat to be the direction of the acceleration, and J hat perpendicular to that. Either away from the ramp or towards the ramp, it does not matter. Do you have a preference?
Up.
Ish. It's up and to the right. Up is that way. It's going that way. So there's my J hat. So that's my coordinate axes, my decomposition. So now I look at these three forces here. Are any of the forces not in the plus or minus I hat direction or plus or minus J hat?
The weight.
Yes. Y is in the J hat, F is in the negative I hat, weight we need to break up. So weight acts down, and I'm trying to break it up into perpendicular components. One of them is in the I hat direction, one of them is in the J hat direction. So I'm gonna have a vector here and a vector here. So the question is, I have some angle down here of theta. Which one of these angles is theta? So, I know that angle there is theta, because that's pretty much the same thing. That is the same thing. That line should be parallel to the ramp. If that's theta, and that is a right triangle there, what is this angle right here?
That'd be theta, right?
Pardon?
That'd be that would be theta.
Theta would be the opposite side of that,
Yeah.
right?
So
When you say opposite side of that, I narrow that one
The
down?
one that you pointed out with the two lines with theta.
That would not be theta.
90 minus theta?
Yes, it's the complement. This is the complement of theta. I typically label that as theta prime. You want to label it as something else. So now I look at, so my green triangle, I see that that's theta prime. Now I look at this triangle right here. That's a right angle. That's theta prime. What is this angle down here? Yes. So I'm breaking weight up. I have weight acting down. I'm breaking it up into its perpendicular components where this angle down here is theta. So which one of these is sine and which one is a cosine?
Sine is on the top right, and then cosine will be at the bottom right.
So we have w sine theta, w cosine. So I'm basically saying that the sum of these two vectors is the same as this. These two add up to that. So my force diagram changes slightly. I have y acting this way. I have friction acting this way. I have w cosine theta acting into the ramp and w sine theta acting down the ramp. That's the decomposition.
And then we just follow the normal procedures as before.
So now it's gonna be w sine theta minus f is equal to ma, y minus w cosine theta is equal to 0.
Alright.
Now,
So you need to use decomposition when there's something in negative I hat or j hat direction?
you need to decompose when it is not along the axes.
Oh, okay.
If it's some combination of I hat, j hat, k hat, you need to break it up. Questions? All right. Back to force diagrams. Because we haven't gotten to the test level problem yet.
So
Two boxes on different ramps. Laura?
I just wanna ask